Good evening, everyone. I, Dr. Kushleen Kaur, co-coordinator of this FDP, welcome you all on the behalf of entire Khalsa College of Engineering and Technology team. Today is the second day of 6 days ATAL FDP. We have a very first speaker with us, Dr. Sheetal Soda, an accomplished academic and researcher with over 15 years of professional experience in mechanical and industrial engineering. She holds her PhD from NIT Jalandhar, specialized in green supply chain management. She is serving as assistant professor at NIT Jalandhar in the Department of Industrial and Production Engineering and teaching undergraduate and graduate courses. Dr. Soda has extensive publications record in high-impact journals, conferences, proceedings, and book chapters. Today, her topic of the day is Industry IoT, connecting machines and systems for smarter manufacturing. Over to you, ma'am.
Yeah, good evening, all of you, and thank you so much, Dr. Kushleen ma'am, for such a nice introduction. I am very privileged to be here to share my thoughts on the topic of IIoT today. Welcome to all the participants.
Thank you, ma'am. Thank you.
Thank you, ma'am.
So, can I start my lecture?
Yes, ma'am.
Okay, just give me a minute so that I can share my screen with the participants. Ma'am, PPT is visible?
Yes, ma'am. Yes, ma'am.
Yes, ma'am, it is visible.
Okay. Okay, good evening once again, participants and the organizers. Ma'am has already introduced myself. Again, those who are joining late, I'll introduce again. I am Dr. Sheetal Soda, Assistant Professor in the Department of Industrial and Production Engineering at Dr. B.R. Ambedkar National Institute of Technology, Jalandhar, Punjab. So, participants, welcome to today's session on the Industrial Internet of Things, connecting machines and systems for smarter manufacturing. For you, this is the second day of the program, and for me, it's the first day. And as far as today's session is concerned, we are going deep into the Industry 4.0 era, where we are going to learn how smarter manufacturing, which is transforming manufacturing processes, taking a new turn. So this particular session, participants, I made in such a manner so that you get a comprehensive understanding of IIoT. My PPT includes the introduction of the IIoT. For IIoT to understand, we should also first understand the Industry 4.0 IoT, and then we will switch to the IIoT. So here we are going to learn about the manufacturing and the other industries, how IoT is changing the trend and it is becoming the cornerstone of the smarter and the more efficient systems. So today we are going to learn about the IoT, its applications, challenges, benefits, and all in much detail. So to start with, before starting the IIoT, we should have a slight introduction about the Industry 4.0. And I think you all, most of the participants have some idea about the Industry 4.0. When we talk about the Industry 4.0, we can say it marks the fourth industrial revolution, which is built on the previous revolutions, which is on the mechanization for Industrial Revolution 1, mass production, Industrial Revolution 2, and automation, Industrial Revolution 3. Now, by incorporating digital and smart technologies, we are here in Industry 4.0. Let's think about how factories which are operated 50 years ago, they relied on the manual labors, basic machines. And if you compare now that today's factories where we are using robotics, data analytics, and artificial intelligence to optimize each and every processes. So the goal of Industry 4.0 is to we have to create a system that are interconnected, automated, and that are capable of self-optimization. So these systems use data to not only respond to changes, but we are also predicting and preventing issues before they occur. So let's take a simple example that suppose we have a factory and a factory where we might use sensors which detects the wear and tear on machinery. This is a very simple example, means a factory is using a sensor to detect wear and tear and machinery and schedule maintenance. So before it breakdowns, we have the information then when the particular thing is going to occur. So Industry 4.0 is hot topic, which is transforming the way factories operate. And as I told you, it is the fourth industrial revolution, which is being characterized by the use of advanced automations and digitalizations technologies in industrial process. So in Industrial Revolution, we talk about the Internet of Things, cloud computing, artificial intelligence, robotics, VR, AR. These are the other things which enable us to for the creation of a highly connected and intelligent production environment. The result is an increase because of this Industry 4.0 or the fourth industrial revolution. We have a result in the form of the increased efficiency, increased productivity, and the product quality, you can say. So when we talk about the Industry 4.0, there are number of different technologies involved under this. We can say the key technologies which are driving the Industry 4.0. So this Industry 4.0, which represent the integration of all the digital technologies we are talking about in terms of IoT, AIoT, advanced robotics, all these are actually reshaping our industrial manufacturing and making it more efficient, flexible, and sustainable. But the question arises, how can businesses harness the full potential of these technologies and what challenges must they overcome to succeed? So we are not going in detail in this particular lecture about all the technologies involved in the Industry 4.0. Our focus is only on the one technology, that is IIoT. So before switching to the IIoT, we should first talk about the IoT. So here in the slides, participants, you can see there are a number of technologies written here, which are the key technologies which driving the Industry 4.0. So first and the foremost is the IoT, that is the Internet of Things, which connects devices to share and analyze data. So we have number of devices which are interconnected to each other. By the help of sharing of the data, we can analyze the data. Second technology is the artificial intelligence. In brief, we can say that this technology enables us to learn and make decisions. Another important technology is the advanced robotics. So advanced robotic, by the help of the robots, we are automizing the tasks which are beyond the human capabilities. Next, we can talk about the cyber security. In cyber security, our main aim is, we can say, the protecting our interconnected systems from threats. Another important is the additive manufacturing, which we called as a 3D printing, also used for the customized parts on demand. Then we have big data analytics that use the processing of the vast amount of data for insights. So we have number of key technologies if we talk about the Industry 4.0. Out of this, today's topic is on the Internet of Things. So, but when we talk or when we are discussing the Industry 4.0, then we can say that these key technologies help us, or the combination of these technologies help us in creating a synchronized and a very, very high efficient system. We can take an example of any, say, automobile plant where we are using robotics for assembling vehicles, or AI for the quality control process, and let's say IoT to track the supply chain in real time. So all these technologies combined together under the umbrella of this Industry 4.0, we are creating a highly efficient system. So there are other technologies are also there for the Industry 4.0, and we can talk for a long about all these technologies, but today's focus is on the IIoT. So to understand the IIoT, we should first understand the key technology of the Industry 4.0, that is the IoT, Internet of Things. IoT, which involves connecting the machines, computers, and people to enable real-time collection and data collection and analysis. See, this IoT, which is connecting the things, whether in terms of devices, people, and system, these allow them to exchange the data in the real time. We can take a daily use example. Most of us use a wearable fitness tracker monitor in terms of smartwatch or smartphone, which monitors our health. And the data received by that smartwatch can be shared, that data can be shared with our doctor so that respective measure can be taken. Another example of this IoT technique or technology is the, we can take a smart thermostat, which which learns our preferences and adjusts the temperature automatically. So this thermostat can be in any of the device we are using in our daily life. So we can say that in industrial settings, this IoT technique enables real-time monitoring and data-driven decisions. So, for example, if we are comparing it with an industrial point of view, let's say if we have a factory where we implemented or install sensors on the machines, which those sensors alerts the operators, say, about overheating of the machines or any irregularities in the routine work of the machine. So that sensor helps us to prevent the downtime, time and the cost also. So IoT enables real-time monitoring and data-driven decisions. So we can
Ma'am, your voice is stopped.
solutions to reshape your organization. Leaders depend on the industrial IoT across the value chain to make enterprise-wide impact, from how they design, manufacture, and service products to how they create value and engage with the customer. So we can say this Internet of Things or IoT is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people. We can consider all these things which are provided with a unique identifiers. And the ability, IoT has the ability to transfer data over a network without requiring human to human or human to computer interaction. The most important thing. And in IoT, when we are talking about the term thing, then this thing can be a person, a animal, a machine, anything on which or we are monitoring the information. So that becomes a thing in IoT. So any on a thing, we can assign an IP address which is able to transfer data over a network. So IoT, we can define in another term that it is a sensor network of billions of smart devices that connect people, systems, and other applications to collect and share data. So participants, when we are saying the Internet of a Thing technology, which is one of the key technology of the Industry 4.0, then we can say it's a concept where we are connecting a device, say with an on and off switch to the internet. And we have a number of examples starting from, you can say your mobile phones, washing machines, headphones, lamps, where any devices, coffee maker, almost anything else we can think of. So these are the daily use example, and it also applies to components like big machines, jet engine of an aeroplane, or any big machine. So this IoT is we can say, a big or a giant network of connected things, which includes obviously people also. And the relationship will be between people, we can say, or between people and things, or between things and things. So IoT is a giant network of connected things. And this giant network of connected things is a dominant consumer IoT device. If we want to take a most commonly used IoT device worldwide, then we can say it's a smart TV. One of the study says that around 30 to 35% of consumers worldwide are using a television that connect to the internet. So there are other areas of the IoT in the market also, which are growing rapidly. Now, why IoT? See, this IoT is so critical. Critical in sense means it offers so many or several advantages to businesses. So organizations in a variety of industries are using IoT to operate more efficiently, in a better manner, to understand customers, to deliver enhanced customer services, improve decision making, and increase the value of the business. So when we are switching ourselves to IoT, then the advantages of this IoT includes, we can say it improves the efficiency. How it can improve the efficiency? By automating means in an industry, we have number of tasks which are repetitive in nature. So we can automate that task by using the IoT and optimize the process. So automatically the efficiency increases. Then other major advantage of IoT, we can say, it helps us to understand the customer behavior, or by increasing the customer insight. It enables better understanding of customer behavior. By the help of the IoT, we get the data for the different types of strategies. IoT also helps in cost savings by reducing the waste and the downtime. For example, let's take an example where we can relate how this IoT is helping us in number of ways. For example, let's take an example of any logistic company, say. And in a logistic company, we are using IoT for, let's say, tracking of the shipments and the deliveries in real time based on the traffic conditions. So this IoT will obviously improves the delivery time, and because there is an improvement in the delivery time, the customer satisfaction will also improve. So this is, participants, this is just a simple example of using of a IoT. So if we talk about the IoT ecosystem, then this IoT ecosystem, which consists of a web-enabled smart devices that use embedded processors, sensors, and communication hardwares, which collect, send, and act on data they acquire from their environment. So IoT ecosystem includes, we have smart devices in IoT ecosystem, which are equipped with sensors and processors. Then we have gateways which connect devices to networks. Then in IoT ecosystem, we have cloud platforms which store and process data. And finally, we have the users which interact with the systems through different apps or the, we can say, the dashboards. So you might have heard of like smart home system, where we have, and even some of you might be using also, like we have smart lights, thermostats together, data, communicate with a central hub, which in which we can further use the cloud computing to analyze the data and automate the process. So in IoT ecosystem, we are basically sharing the sensor data they collect, which is by connecting to an IoT gateway or other edge device, where data is either sent to the cloud to be analyzed or analyzed locally. So participants, now once we learned about the Industry 4.0 and it's one of the key technology IoT, then it will be easier for us to understand the today's topic, that is the IIoT. The slide you are seeing, participants, here you can see the IoT applications which we have have just discussed also, whether it's a smart TV or smart homes or wearables or smart car. These all are some of the important applications of our daily life. And if we talk about the manufacturing, IoT in manufacturing, then again, it's have number of applications in manufacturing sector also. Like for example, real-time equipment monitoring. Where in real-time equipment monitoring, I have just quote you an example of a logistic company. Participants, please.
Participants are requested
switch
to
off
kindly
your
mute their mics, please. Participants are requested to mute their mics, please.
Yeah, now it's better. No, someone mic is still on.
I'm checking. Ma'am, it's sorted, please. You can continue.
Okay, ma'am, thank you. Okay. So, I was telling you about the application in manufacturing of this IoT. This IoT is transforming manufacturing in number of ways. For example, if we talk about the real-time equipment monitoring, and I have just quoted an example of a logistic company where sensors are used to track the shipment movement and any congestion in the traffic. So this real-time monitoring is one of the key application of IoT in manufacturing, where sensors track the machine performance. Similarly, we have the predictive maintenance, where artificial intelligence analyzes the patterns so that we can predict the failures beforehand. Then we have a supply chain tracking system, which ensures end-to-end visibility of each and every stage of the supply chain. Then we have the energy management, which helps us to optimize the energy usage to reduce cost. For example, if we want to have an example for this application of IoT in manufacturing, then we can take an example of any company, say any beverage company, which is using this IoT to monitor the temperature of different, say, refrigeration units across different facilities or multiple facilities. So if a beverage company has multiple facilities and we are using IoT to monitor the temperature of the refrigeration units in different multiple facilities, and if one unit, say, malfunctions due to any reason, then alert is immediately sent for repairs and another unit will take care of that malfunction. So this is how IoT can monitor the things in manufacturing industry. So manufacturing industry is revolutionizing through smart connectivity. Till now, we have discussed some points on the Industry 4.0 and some detailed discussions on IoT. Now, this particular slide gives us the view that IIoT is a subset of Internet of Things, which is nothing but a industrial Internet of Things. One extra I is added to the term IoT and it becomes Industrial Internet of Things, which focuses on industrial applications of IoT, particularly in manufacturing, or we can say logistics or any other utilities, where we are using smart sensors and devices to connect our machinery and processes. So, IIoT or the industrial IoT involves the use of smart sensors and devices in industrial operations. And this is the foundational technology for Industry 4.0 initiatives, which is taken in terms of the IoT technology, which are using the smart sensors, actuators to connect people, product, and processes to power or digital transformation. Using this industrial IoT platform, companies can connect, they can monitor, they can analyze and act on industrial data in new ways to improve efficiency, maximize revenue growth, reduce cost, and more. So, IIoT, which integrates smart devices, sensors, and advanced analytics to improve manufacturing processes, it's a critical component of Industry 4.0, which enables real-time data exchange between machines and systems. See, while the physical systems are made the intelligent using IoT, the real-time communication and say cooperation between each other with human is established through via the wireless web. So we can say this IIoT is bring the concept of that a connected factory leads to a smart factory. So here IIoT focuses on the use of cyber physical systems to monitor the physical factory processes and help us to make data-based automated decisions. So the factory which is connected leads to a smart factory. And this is the base of a industrial IIoT. So here we can see a picture of a smart factory. So we can see the number of advantages of switching over to smart industries, whether in terms of a predictive analytics, whether in terms of efficient and productive processes by using the sensors, whether in terms of the assets of a management using the robotics and safety operations. There are other advantages also for the smart industries. So a smart factory where all equipment is connected, where the system monitors the production in real time, flag issues, and adjust operations itself, or we can say adjust operations automatically to meet the demand. So this is what today's world is, that is the smart industry. Now in IIoT, we have number of key components to understand. Starting with the first key component of IIoT, that is the smart devices and sensors, which collect data from the machinery or capture data from the machinery. Then another key component of IoT includes the industrial gateway. The function of the industrial gateway is that it helps us or enable communication between devices and cloud platform, or we can say it act as a bridge between the device and the cloud platform. Then we have the connectivity protocols. These connectivity protocols, for example, Wi-Fi, Bluetooth, and Zigbee, these help us to ensure seamless connectivity so that there is no hurdle or intervention between the connectivity. Another key component of IoT is the cloud platform. The function of the cloud platform is to store and analyze the data, or especially the large volumes of data. Then we have the AI and the ML, or the machine learning and the artificial intelligence, which generate actionable insights. So these generates actionable insight from the data stored. Then another key component is the security system, which protects the IIoT system for the from the cyber threats. Okay. So by the help of these key components, we can easily implement the IIoT in industry. Now here our focus is on the manufacturing industry. So this slide helps us to understand the impact of IIoT in manufacturing. So IIoT application in manufacturing, or its impact in manufacturing, include number of things, and the main applications in manufacturing includes like we can do the inventory management with real-time updates. We can do quality control. We can optimize the logistic. So anything in manufacturing industry can be linked with this IIoT. So for example, a factory which might use IIoT, for example, to ensure the, let's say, whether the raw materials are fully stocked to meet the production schedules or not. So there, this IIoT plays an important role. And if we want to learn the different number of impacts on the manufacturing, then this includes these things we have just discussed, that it helps us in enhanced connectivity and communication. It helps us in predictive maintenance, efficient resource management, quality control, safety and collaboration, data-driven decision-making, agile and flexible manufacturing. So all these are the different impacts on in manufacturing of IIoT. So this is a picture where in an industry and IoT is implemented, and so if we talk about IIoT in manufacturing, then we have number of different areas where we can talk in detail about this in any manufacturing industry. So I have jotted down a few points for explanation of this particular things, that is IoT in manufacturing. So to start with, first is the digital or connected factory. So participants in digital and connected factory, IoT enabled machinery can transmit operational information to the partners. For example, like original equipment manufacturers and to field engineers. So the factories, the factories are digitally connected, and those we termed as a IoT enabled factories or IoT enabled machineries, which are using to transmit the information related to the any operational information and any other information required to the one of the manufacturer or to other engineers. So this is one of the major applications in manufacturing, that is the digital connected factory. Next important thing here comes the facility management. So in facility management, we can use the IoT sensors in manufacturing equipments, which enables, we can say, maintenance alert or condition-based maintenance alert when we required any maintenance depending on the information collected from the sensors. Next, we have the production flow monitoring. In production flow monitoring, this particular feature, we can say, help or enable us to monitor the production line, starting from you can say any refining process or any initial process, say extraction of the raw material to the final packing of the material. Means starting from the initial input to the final output, we have a production flow process, and by the help of this IoT in manufacturing, we can monitor this production flow process. So this is another area where we can use this. Then we have the inventory management. And in inventory management, this IoT application permit the monitoring of events across the supply chain. Means specifically in the inventory management, it can give us the real-time picture of the inventory stock. Then we have the plant safety and security. Here we can use IoT, which can combine, we can say, big data analytics, and it will help us to improve the overall safety. We can have the IoT sensors for quality control, which can aggregate the entire product data, and if there is any third party data is required, we can collect the data from there also, or from various stages of a product, to have a better quality control. Then we have it can be implemented in packaging optimization, again by using IoT sensors in product or in packaging packaging. The manufacturers can have the insights about the patterns and handlings of the products from multiple customers. So this again help us in optimizing the packaging behavior. And last is the logistic and supply chain, and supply chain optimization. Again, this industrial IoT can provide access to real-time supply chain information. When we talk about the real-time supply chain information, then we are concerned with like tracking the real-time of the tracking of the materials, real-time situation, equipment, and product as they move through the different phases of the supply chain. So these are the important areas in manufacturing where IIoT plays an important role. Now, participants, there are a number of, we can divide this industrial IoT into different areas, but the most important area we are talking, especially in terms of the manufacturing, is the smart factories. And in smart factories, by implementing the Industry 4.0 strategies, by the use of industrial internet, we have the factories of the future. So, smart factories are interconnected network of machines, communication mechanisms, and computing power. The smart factory we are talking here are nothing but a cyber physical system which are using advanced technologies such as AI and ML to analyze data and drive these automated processes and learn as it goes. We can say these are interconnected networks which are using different key technologies of Industry 4.0, whether in terms of AI, IoT, robotics. And these factories achieve unprecedented levels of in terms of, say, whether in terms of efficiency, safety, sustainability. So these smart factories are nothing but these are the transition to IIoT, which involves by adopting the Industry 4.0 strategy so that they stay competitive. So today's smart factories leverage innovative technology and data to achieve a level of manufacturing performance unsurpassed in history. So this slide gives an overview how IIoT or IoT in smart factories works. Here you can see we have the network where we are collecting the data, analyzing the data. This is the IoT platform. This is the IoT device. This is IoT hub, and number of data and command are going and coming in from the different machines. From the machines, we are collecting the data, and this is how the smart factory works specifically in a manufacturing industry. So by implementing Industry 4.0 strategy, we can have a smart factories. So here, what do we mean by implementing the Industry 4.0 strategy? That manufacturers are integrating new technologies, including the key technology of Industry 4.0, whether in terms of IoT, cloud computing, AI, and machine learning, into their production facilities and throughout their operations. So Industry 4.0 concept and technologies can be applied across all types of industrial companies, including discrete and process manufacturing, as well as we can talk about the big industries like oil and gas, mining, and other industrial segments. Now, till now, we have learned a lot about IoT and IIoT, specifically in manufacturing industry, and about the smart factories. Now, how this IoT actually works. So there are a number of different steps, or we can say methods that we can learn to understand how this IoT works. So the different steps involves to understand its working include, first is the data collection. Data collection means here we are using sensors which capture operational data from the machines. Then that collected data is transmitted via connectivity protocols to the cloud. All these things we have already discussed I have already discussed in my previous slide, where I talked about the key components of the IoT. First is the data collection by using the sensors. Then we have to transmit that data via connectivity protocols to the cloud. Then we have to analyze that data which we have received by using artificial intelligence analytics tools to derive actionable insights. And finally, we have to take decisions. And these insights help us to apply the optimization or to automate the process. So when we are saying the steps which we should adopt in implementing IoT in an industry, then we should first do the field device platform selection. And once the selection is done, we have to determine the communication, how communication can be done. Then we have to determine the cloud platform, then the web application development, and then we go live and do the maintenance part. So in detail, we can go step by step to implement IIoT in manufacturing. While learning the steps to adopt IIoT in manufacturing, we should first assess needs. Means we should first identify the goals and the key pinpoints, what you require to achieve, what is the need. Then once you assess the need, the next important step to understand is that we should start with the pilot project, or we can say we should start with the small. Implement pilot project before scaling. Means before doing any big, we should first do in a small scale. Then we should be careful while choosing the right technology. So we should select the correct solution or the right technology. And after that, we should also be aware of the security point of view for the technology we are using. And once we have framed all these things, we should train the workforce who are actually going to use this. So we have to upskill our employees for this IIoT integration. And finally, when we are done, we have to monitor and improve based on the data we have collected. Sorry. So when we talk about the different steps before going the detailed step-by-step procedure, we have to first assess our needs. We have to identify the problem. Then we have to define the goals. Then we have to choose the team. Then we have to analyze the what we have in our hand. Currently, what is the system is all about. And according to the current system, we have to choose the IIoT platform. And then we have to choose the technology. And in choosing the technology, we have to first connect the devices, collect and analyze the data, and then implement the changes. And when we are done with the implementation, after that, we have to monitor and optimize. And once we are done with the pilot project, then the important things comes that we have to train the workforce, upskill the employees so that the IIoT integration can be done. And this is a continuous process. You have to do the same cycle again. So this is just a slide to show how IIoT can be used in manufacturing. Now, participants, once we are done with how we can adopt IIoT in manufacturing, we will move to some of the applications of the IIoT in manufacturing, especially in real world. Smart factories are the very common examples which we have just discussed, where we are doing the automation and optimizing the production lines. Then we can do the digital twins, where we can have the virtual models of physical assets for simulations and analysis. Then another example is the predictive maintenance in action, where we can detect any error or any wear and tear in machines. We can early detect if we follow this predictive maintenance in action. Then supply chain optimization can also be done by the help of the real-time tracking and the inventory insights. So these are some of the real world applications of IIoT in manufacturing. Now, if we talk about the applications of IoT in the manufacturing sector, there are a number of applications. Some of these applications we have already discussed. Others includes like intelligent product enhancement, quality control, predictive maintenance, inventory management, product safety, improved facility service. dynamic response to market demands, and smart packaging. This slide helps us to have knowledge about some of the major industries which are using this technology of the industrial IIoT. So we have Bosch, Airbus, Fanuc, Komatsu, John Deere, BlueScopes are some of the industries which have been already switched over to this industrial IoT. Now, there are number of benefits of IIoT, specifically in manufacturing. Industrial IoT systems. These systems are made powerful due to or by connecting devices and machines, which can we can say these devices and machine can speak the same language, monitors, and analyze the we can say the performance of an industry or industrial performance data, and simultaneously allow real-time visibility into means what's going right, what's going wrong, and even they can predict on when something will go wrong by the help of the predictive maintenance. So we can say a connected IIoT ecosystem gives the industry the power to enhance efficiencies. This also helps in remotely monitoring the things, benchmark, we can say maximize uptime, optimize operations in factory, and the we can say the things are limitless. So the best way as an manufacturer or industrialist, we can say, to we should accelerate this digital transformation by using or implementing a proven IIoT platform. That's the main purpose. So an established platform, the companies which are already using this IIoT witness the number of advantages. Okay, whether to start with, we can say this IoT in manufacturing helps in maximizing the revenue. By how this IoT helps in maximizing the revenue by we can say eliminating the unplanned downtime and any operational roadblocks. So it helps us to scale new markets, unblock new business models. So all these things help us to increase the or maximize the revenue. Another important benefit is it reduces time to market. The assets for new functionalities. It also lowers operational cost. Lowers operational cost means by removing bottlenecks and increasing the efficiency, it helps us in lowering the operational cost. It also helps industry in improving quality by scaling the service and the operation. The quality and customer satisfaction, reliability, all these things improve. Other things which are mentioned in the slides are like it improves the productivity by automation, by reducing the human interventions. It enhanced supply chain management by optimizing inventory and logistic. It predictive maintenance by, and we can say by anticipating any prevent downtime or any machine failure. It also enhanced quality control by giving the real-time monitoring. It increased efficiency, or rather efficiency, we can also say the energy efficiency by reducing power consumptions through data insights. And about cost reduction, I have already discussed that it maximized the revenue and reduce the time period. So there are a number of benefits of switching to IIoT in manufacturing, but along with benefits, we have certain challenges also. So challenges in implementing IIoT include high initial investment, because we are switching over to our current system of infrastructure or our current setup to a new setup. So, and this IIoT requires a high initial investment of upgrading the infrastructure. Next challenge comes in the difficulty while doing this upgrading infrastructure. Difficulty arises in integrating with the older system. There are number of different kinds of challenges comes when we switch over to the older system to the IIoT. So we have integration and legacy system compatibility issues with all older equipments. Then cyber security risk, which is one of the major challenge with the IIoT, of hacking and data breaches. Then we have data management issues because we have to analyze a large amount of data here. Shortage or the lack of skilled workforce, which is the need for the IoT skilled professionals. And because IoT devices are closely connected, all a hacker has to do, we can say, is exploit or manipulate all the data and rendering it unstable. And if manufacturers that don't update their devices regularly, then the condition will get worse. So means hackers are not only threat to this IoT, privacy is another major concern, we can say. If companies, because companies are sharing the data with number of different at number of different stages, which make and distribute consumer IoT devices, and that can be used devices to obtain or sell users' personal data. So the hackers are one reason of this cybersecurity risk, but the sharing or the privacy is another major concern for the IoT users. So security of data, reliability, connectivity of all the systems in IoT setup, blending legacy system, all these are the key challenges where we have to work to overcome these challenges. So now if we talk about the future of IoT and specifically in manufacturing industry, then the future promises the autonomous factories, where we have the real-time monitoring and the predictive maintenance, efficient resources utilization, improved or the enhanced product quality, optimized supply chain, better safety and compliance, scalability and flexibility. The future of manufacturing, if we talk about in terms of a real-time monitoring and predictive maintenance. Here in IoT, we are using sensors placed on machinery, which can continuously collect data on equipment performance and environmental conditions. If we talk about the efficient resource utilization, then in efficient resource utilization, by analyzing data from various sensors, manufacturers can make already informed decisions about any raw material usage or any equipment deficiency. So this is one thing. Next, if we talk about how we can improve the product quality, then again, IoT can play a important or a crucial role in quality control by giving the real-time data on the production process. And for this, it helps us for the early detections of defects, or we can say, if we talk about the quality, and if there is any deviation from the benchmark or the quality standard, which have been already set, then it will also informed in an advance. Then we have a supply chain optimization. In supply chain optimization, by connecting, say we have different phases or these stages in the supply chain. So by connecting the suppliers, manufacturers, or the logistic providers through this IoT device, entire supply chain processes can be, we can say, optimized for efficiency and the transparency. So this is again the another parameter or the thing we can look for in supply chain optimization. Then if we talk about the safety and compliance, in safety and compliance, like in IoT, we are using the sensors. Sensors which can monitor the conditions or any current situation. So if there is any breach, or if there is any safety breach or non-compliance with the regulation, then real-time alerts can be triggered. Okay, so this thing can be done in the future. And another important thing is the scalability and the flexibility. These IoT solutions are designed with scalability and flexibility in mind. Means new sensors and devices can be added. The system should be feasible or flexible enough that any new implementation can be easily adjusted by the current situation. So new sensor and devices can be added and existing ones can be reconfigured so that we can accommodate the changes in the production. Okay, so these are the important areas for the future of IoT in manufacturing. So participants, to conclude my presentation, we can say that IIoT is transforming manufacturing by connecting machines, systems, and processes. And we have discussed the benefits also, which includes enhancing the efficiency, cost savings, and improve quality. Along with benefits, yes, we have challenges also, and the future, despite challenges, the future of IoT is promising with advancements in technologies. And the companies embracing IoT gain a competitive edge in the era of Industry 4.0. IIoT connects machines, systems, and processes, and making these things smarter and as well as more efficient. Yes, there are challenges, but its benefits are undeniable and which gives companies a competitive edge. So we have learned that IoT transforms manufacturing by connecting machines and enabling smarter systems. And now there is a need or a call to action to emphasize the need for adaptability and innovation in adopting IIoT. So, to conclude, IoT is not just a trend, it's the future of manufacturing. Thanks for your attention and for your patience listening. I am now open to questions.
Participants, any kind of questions?
Participants, if you have any questions, any doubts, you can ask. Any doubts, participants?
Hello, ma'am.
Yes.
Hello. Yeah, this is Shailesh here.
Yes, sir.
Ma'am, thank you for the session. Actually, I'm whatever doubts, whatever I having, got completed by your session, which will
Okay.
help me to let me introduce this topic to my students. So thank you very much.
Okay, thank you.
Yeah. Yeah.
Thank you, ma'am. You explained it very well in very simple language. Thank you so much. It was a wonderful session.
Okay, participants, if you have no doubt, then I'll conclude my session. Thank you, Dr. Khushleen. Thank you, Dr. Ripin Kohli, ma'am.
Thank you, ma'am.
Thank you, ma'am. It was wonderful having you with us. And we will
My
be
pleasure.
soon having you on another day on 11th of Jan.
Yeah,
Right,
I will be
on the
there.
concluding
Yeah.
session. So we are looking forward for that session also. Thank you so much,
Yeah.
ma'am, for sparing your valuable time for today.
Thank you. Thank you for the entire team. Thank you. Thank you.
Thank you, ma'am.
Thank you.
Participants, please wait for the next session. Our speaker will join shortly.